Now we are going to the second question. Four structures of chair forms of cyclohexane, dimethyl and trimethyl cyclohexane are given here. One is this in the form of A, B, C and D. Four questions have been asked on that basis. On the basis of these four structures represented by the formula, represented by the alphabets A to C, A to D. The first question is, which one of them, question number A, there are three questions that are asked there. Actually, four questions that are asked there. First question is, which one of them are constitutional isomers? What are actually constitutional isomers? Constitutional isomers are those which have different structures. They are not stereochemical isomers. Which one of them are constitutional isomers? The answer to that question A is C is actually the constitutional isomer of A and B. There are two methyl groups attached to this in 1 and 3 position. This also two methyl groups are attached to 1 and 2 positions, whereas in this the two methyl groups are attached in the same position. Therefore, A, B and C, they are all constitutional isomers, and therefore you can say that C is the constitutional isomer of A and B. That is the answer for this question. Constitutional, which one of them among this are the constitutional isomers? The second question is, which one of them are stereoisomers? The difference between stereoisomers and constitutional isomers being, stereoisomers differ only in their position, geometrical arrangement, or the position of the various groups that are present in the same compound. The same groups are present, the same formula is present, and the various positions, geometrical disposition, that is why it is referred as a stereo. The spatial arrangement of the various groups, that is referred by stereoisomers. For this question, only A and B are the stereoisomers, because the two are di-equatorial. Any group which is arranged vertically is referred as axial, and anything which is arranged in a horizontal fashion is referred as di-equatorial. Is known as equatorial. In this case, both the groups are equatorial, so this is di-equatorial, whereas this is axial equatorial. One is axial, the other one is equatorial. A is axial equatorial and this is di-equatorial. Di-equatorial is actually cis and axial equatorial is trans. Therefore, for this question B, A and B are cis and trans isomers, whereas this is known as trans and this is known as cis. So that is the answer for the question, which one of them are stereoisomers? For the answer to this question is A and B are stereoisomers, of which A is trans and B is cis. Now coming to the third question, which one of these compounds will have the highest value, delta H, heat of combustion value? As we had discussed in the earlier question, any compound containing, organic compound containing the highest number of carbon atoms will have the highest amount of value of the heat of combustion. In this you will find D has most, because in all the other cases we have only two, the same cyclohexane ring is there, we have only two methyl groups, whereas in this case we have three methyl groups, so the molecular weight is up by 15 units, therefore this should have a higher value. So of all these, D has most number of carbon atoms, and therefore D, the delta H of combustion, heat of combustion value for this compound D is highest. Then the fourth question is, which one of them is trans? This has already been discussed. They are among the stereoisomers. To make it more clear, which one of them, the fourth question asked is, which one of them among these four is trans in nature? Here we cannot fix up cis and trans because there are more than two groups. These two methyl groups, in this case, in the case of A is trans and this B is cis. Therefore, the question asked is, which one of these among the four is trans? The only trans configuration can be given, stereochemical assignment trans can be given only to the compound A and not to other compound, because B is cis and there are more than two groups or something like that, same group, two groups attached to the same, so that those concepts cannot be applied to this. Therefore, the trans is only A.